The next symbol that we need to address in this section is a symbol that you guys have seen quite a few times, but maybe not in mathematics, and that's the exclamation point. And in mathematics, the exclamation point means factorial. And a factorial simply means that we want to take the product of all the numbers, or all the integers, from 1 to whatever that number is. So if we had, for example, n factorial, that would be equal to the product of all integers from 1 to n. Right? So it would really equal 1 times 2 times 3 times 4 times all the way up until we got to n. Where this is used quite a bit in mathematics is when we're looking at doing some probability and counting, which is good because that's where we're going to head next. And we use it a lot when we're talking about permutations. And permutations are the ways that they're the arrangements of an object. So they're arrangements of objects, such as how many different ways could we rearrange the letters in a word, or put books on a shelf, or a more common problem that we'll look at right now is how many different ways could 4 runners finish a race. So if we've got 4 runners in a race, and we want to know how many ways can they finish. Now, the important thing with permutations is that order matters. Obviously, finishing first is going to be a whole lot different than finishing fourth or finishing second. So it's important that we know how many different orders there are for running the race or for finishing the race. So in elementary school or maybe early middle school, you guys probably would have gone through and done the problem this way and said that, all right, there's 4 positions. You could be first, second, third, or fourth. And what happens is you've got 4 runners in the race. Any of them could finish first. Once first place is decided, you have 3 runners left to see who could come in second. Once first and second place are decided, there's 2 runners left in the race that neither of them could finish third. And once the first 3 places are decided, there's only 1 person left to come in last place. So if you multiply that out, notice 4 times 3 times 2 times 1, we get 24. But now the shorthand way of writing that, which is, again, what this section's all about, is using math symbols to shorten up these common operations. We would just say that this was 4 factorial. And again, that's equal to 4 times 3 times 2 times 1, or 24 ways. So hopefully it'll save us a little bit of work in the long run. We won't have to write out all of these spaces and then walk through the logic that way. Now, is there anything wrong with that method? If you understand it, no, by all means. Go back through and make the lines and the spaces and put the numbers in and multiply them out that way. If you're comfortable knowing that permutations lend themselves well to factorial, and you want to go through and just use the factorial, save yourself a little bit of writing, a little bit of time, and go through and look at it like that. Another common problem that's used with factorials would be how many ways can we rearrange the letters of a word. So, for example, if we had the word dog, and I purposely chose a word where none of the letters are repeated. We'll get into that another time. So, how many different ways can we arrange these letters? Now, make sure you notice that we didn't say how many different words can we form. That's a completely different question. We don't care if the rearrangement makes sense as far as how many words there are. We just want to know how many ways could we arrange them. And at this case, when we only have 3 letters, we could probably write them all out. I mean, you could go DOG, DGO, GOD, GDO. We have to put O in the front, so ODG, and OGD. So it looks like we should probably have about 6 ways. And you probably, again, in late elementary, early middle school, would have just listed them all out and said there's 6 ways. And you would have had to list all the possibilities. Now that we know a little bit more about it, you probably would have from then advanced on to say that, all right, I've got 3 letters. Once I choose one to go first, there's 2 letters left. And once I choose one to go second, I only have 1 letter left to look at. So 3 times 2 times 1 equals 6 ways. And now we're getting even more concise with it and saying that, well, we're rearranging the letters and looking at how many different arrangements where order matters. So we've got 3 factorial, which is 3 times 2 times 1, or 6 ways. So, again, no matter which way you want to look at the problem, the main thing is that you understand it and that you can logically argue it if you need to and arrive at an answer that makes sense. And that is it for 13.3. So hopefully you guys understand what the summation and factorial symbols stand for. And we will move on to 13.4 in the next lesson.